Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor. radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses, so it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the parade of planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The two probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space, then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the eighth planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the two facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the Moon on July 20th, 1969. Since then, the Moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the Moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our Moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the Moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the Moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days. Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice. But Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts: water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Whoa, a wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards.